So pause the video and write down this question. So we are starting on the problems on intervisibility. So first problem is pretty simple. We have two stations P and Q, and the distance between them is 81 kilometers, and it is situated in C. The intervening ground is C, and P is of height 39 meters and Q is of height 207 meters. We are asked whether P and Q are intervisible or not. Okay, it's just very simple, the basic calculation, but you have to pay attention to get it. Okay, otherwise it will be a little difficult as we move forward. So in intervisibility problems we will be drawing we are having geodetic surveying. So we are drawing the surface like this. Okay, curved surface, not a plane surface, curved surface, and we are marking P here and Q here. Okay, and P height we know it as 39 meter P. Okay, and Q I'm not drawing it right now. Okay, but instead of that I am from this instrument station at P at 39 meter height, I am drawing a line of sight. Line of sight, and the height at which this line of sight, this is line of sight. Line of sight is the imaginary line passing through the line of coordination of instrument in here which wants to meet Q. Okay, so in intervisibility, if suppose this line of sight meets at Q, which is at 207 meters, these two are intervisible. If not, they are not intervisible. That is the concept. Okay, so this is line of sight which passes through the point of tangency C. Okay, as in last class, point of tangency C, and the height of line of sight is drawn like this. This point, this line, short line, is not the height of Q, not 207. It is the height of line of sight at Q. This thing is, for example, if suppose we are terming it as P1, Q1, and this is actual P. We don't know the actual Q in here. Okay, so if suppose we are naming it as small q, Q1, Q is height of line of sight at B, sorry, Q. Okay, so Q1 is, or Q1 Q is height of line of sight at Q. Okay, so the concept of the problem is very simple. We just want to find out if this Q1 is 207 meter height or not, or if it is less than or greater than 207 meters. Okay, that is the only concept that we are searching for, whether Q1 Q is less than 207 or greater than 207. Okay, we will understand more about it as we proceed. Okay, so we will take this as H1 and Q1 as H2. This total distance can be termed as D, that is 81 kilometers, like this. Okay, and the distance from P to C can be marked like this, and we assume it as D1, and the rest C to Q is marked as D2. Okay, so D, D1, D2. There is no criteria of naming it. You can name as you want, but you have to follow through on the equations as in the diagram. That's it. Okay, so d d1 d2 h1 h2. Okay, and as it is C surface, we cannot use that equation. Which equation? dh is equal to 0.0673 d square, because that equation, simplified equation, is for land surface, where m is equal to 0.07. Right now it is C surface, so m is not equal to 0.07, it is equal to 0.08. Okay, so we will be taking the elaborated equation. Okay, so from this criteria, we are starting from the instrument station. We always be starting from instrument station, and we know h1. Okay, and h1 is equal to 1 minus 2m d square by 2r. We know the values of m and r. Okay, and d1 square, okay, h1 in here, d1, that corresponding distance of that corresponding station to point of tangent C, that is d1. Okay, so from this equation we know everything except d1. So let's find out d1. h1 is equal to 39. We will convert it into kilometers. If it was simplified equation, we didn't need to convert it into kilometers, but in this elaborated one, we need to convert it into kilometers. Okay, 39 by 100,000 is equal to 1 minus 2 into 0.08 d1 square divided by 2 into 6367 kilometers. Okay, so d1, we get it as, after simplification and solving, we get it as 24.32 meters. Okay, so that is d1, this distance 24.32. Okay, get it. Now what is d2? How can you calculate d2 from this figure? The total distance is d, that is 81 kilometers, and the distance from P to C is given as, or we calculate it as 24.32 kilometers. Sorry, kilometers. Now what is d2? Obviously that will be, d2 will be equal to d minus d1, that is 81 minus 24.32 kilometers, that is equal to 56.68 kilometers. This distance is 56.68 kilometers. Okay, so adding both, you will get 81 kilometers. Now we have d2. Then how can you calculate the height of line of sight at Q? h2. How can you calculate? From this same equation, instead of h1 we will substitute h2, and instead of d1 we will be substituting this value. Okay, so h2 is equal to 1 minus 2m into d2 square divided by 2r. Elaborating, 1 minus 2 into 0.08 into d2 is 56.68 square divided by 2 into 6367 kilometers. Okay, indicate it as 0.21182 kilometers. So h2 we get it as kilometers, but we have to compare it with this value. So convert it into meters, that is 211.82 meters. Okay, Then this is the line of sight, height of line of sight at Q. That is, this is 211.8 meters. Q1. So how do you know P and Q are intervisible or not? Okay. So the line of sight is passing through Q at the height of, if this is Q, line of sight is passing through a height of H2, that is 211.82 meters. Okay, so I am taking this only this Q station. But what is the height of actual signal Q? That is only 207 meters. So 207 meters is the height of Q. This is Q. So obviously Q will be lower than the height of line of sight. Okay, so this point is the most important. Q is 207. As height of line of sight, Q1 is bigger than height of signal 207. This will be actual signal Q will be below the height of line of sight. This is line of sight. So the inference is both P and Q are not intervisible. Okay, if suppose instead of 211.82 we have got, suppose we got the value as 205 meters, then what will be the inference? The actual height of Q will be bigger than line of sight height. So this P and Q will be intervisible. Okay, you got the idea. As the line of sight we calculated was bigger than actual Q, line of sight was passing over Q. If it was lesser than 207, it will be touching. If Q was like this, line of sight will pass like this. Then you could see P and Q very easily. From P, Q will be intervisible. Okay, so in this case, line of sight does not meet Q. So P and Q are not intervisible. And what is the solution for this? We have to elevate Q. With 207 height is insufficient for Q to be visible from P. So we have to increase this height. How much? How much we have to increase? The line of sight is passing through 211.82 meters. And actual height is 207 meters. Okay. So this elevating or heightening of Q is called as scaffolding. Scaffolding required at Q is equal to the difference of both values. Line of sight is passing through 211.82 meters. We have to increase 207 height to 211. Okay, so 211.82 minus 207 meters, that is 4.82 meters, approximately 5 meters. That is the answer of this question. I hope you understand this. We had two stations P and Q, intermediate site 81 kilometers at C. P and Q height was given. We took H1 as 39 P and calculated D1, and from D1 and D we calculated D2. Then using that D2 we calculated height of line of sight H2, and that value was 211.82 meters, and comparing with 211.82 meters with the actual height of Q, we inferred that currently Q and P are not intervisible, as 207 was less than 211.82. Suppose this value was less than 207, it could have been, P and Q would have been indivisible. Okay. Then we designed scaffolding required at Q to become visible from P. That is the difference between height of line of sight and actual Q. That is 5 meters, approximately 5 meters. Okay. That is how you calculate intervisibility. And suppose all this was happening on land instead of sea. Okay. Then we will be calculating all these values. Instead of this equation, we will be calculating using the shortcut version. The equation as h is equal to 0.0673 d square. Here, etc. Okay. So most of the time you will be asked to calculate intervisibility problems on land. It was a slight different problem. Okay. So take note of that. So we are moving on to next problem. So in this problem, we are having only a slight change or two details added to our older problem. Okay. So we had two stations A and B with respective heights given, intermediate distance, but you have another point as the intervening ground is having uniform variation of height as 216 meters. Okay. And the line of sight should pass through at least 2.4 meters through point of tangency. That is, I will explain. In usual way, we will start the problem like this. If this are the stations, this can be taken as 243 meters. Okay. This also will be a bit higher. Okay. And this distance is 50 kilometers. Clear? And this is A and B is somewhere here, not accurately, somewhere there. And the intervening ground is this curved portion, is having a uniform elevation of 216 meters. That is, suppose there are mountains or trees, etc. like this, and the uniform elevation for that is given as 216 meters. 216 meter of height. So obviously we cannot pass through, line of sight cannot be considered passing through like this. It should be passed like grazing over 216 meters, obviously. Okay. So that is, there is one more detail. Calculate the intervisibility between these two, considering there is 2.4 meter clearance of line of sight. So in earlier case, we could have calculated line of sight passing through like this, as it grazes through the ground. Okay. But in this case, you are asked to keep a clearance of 2.4 meters. The line of sight shouldn't be grazing through the ground, no tangential, it should be clearing 2.4 meters like this. Okay. So there is another point, 2.4 meters offset. 2.4 meters. Okay, so we have a complicated diagram, not so complicated, but we have two more details added with our last one's diagram. So we want to simplify this. Okay, so how can you simplify this? You will calculate, we can assume that 216 meters and this 2.4 meters are to be cut out from our system. Okay, so what we will be doing is, we will take this 243 meters of H1 and subtract both of these values, 216 and 2.4. Okay, and we get it as 24.6 meters. Okay, and then again we take height of B is equal to 258 minus this elevation 216, same thing we did with H1, minus 2.4, that will be equal to 39.6 meters. Okay, so we have cut out all these two disturbances, 216 meter and 2.4 meters, from these two heights, and we have new heights, 24.6 meter for H1 and 39.6 for height of B. Okay, now we are going to draw a similar diagram using these values as we did in last problem. So this is A and this is B. In this we can graze through the surface because we have cut out the offset 2.4 meters. So don't need to look into that detail now. So this distance will be 24.6 meters and this is A. Okay, and this will be somewhere B. Okay, and as we did in the last time, we will be comparing with 39.6, not with this value. So forget all these things. When we get this similar diagram, this is C, distance is 50 kilometers. This is the new similar diagram, and forget about all this, all the rest. Okay, now we will start doing the problem. Okay, so I am rubbing all the elaborate drawings. Okay, so we have cut it out. Okay, then start with our issue, new issue, that is H1 is 24.6. As it is land, we can take that shortcut equation. The equation was H1 is equal to 0.0673 d1 square. Okay, and d1 is equal to whole root of H1 by 0.0673. Okay, clear? So H1 is 24.6 by 0.0673 whole root, that is equal to 19.118 kilometers. That is D1, that is 19.118. So calculate D2. Same procedure, D2 is equal to D minus D1, that is 50 minus 19.118, that is equal to 30.88 kilometers, that is D2. So from this 30.118 D2, we will calculate H2. H2 is equal to 0.0673 into this equation D2, instead of D2, that is 30.88 square. Okay, H2 is given as 64.176 meters. Directly meter is given. Okay, so in this shortcut equation you will need to substitute D as kilometers and obtain H as in meters. Okay, so 64.176 is what? Point to be noted, height of line of sight at B. Okay, that is H2, height of line of sight at B, that is given as 64.176. So what is the value that should be compared with 64.176 as we did in last problem? That is 39.6. So what is the inference? As if this is B, line of sight is passing through the height 64.176 meters, but B is of height only 39 meters, 39.6 meters, only this much. This is B. So obviously line of sight is passing through over B. So currently A and B are not indivisible, and you have to elevate this distance to calculate to make B visible from A. Okay, so the distance, scaffolding height at B is equal to 64.176 minus 39.6, that is equal to 24.57 meters, that is approximately 25 meters. So the inference is only if you elevate B to 25 meters more than 258 meters, you will be able to see B from A. Then only intervisibility is possible. Okay, I hope you get it. The same procedure, just we had drawn another bigger diagram, and by offsetting these two values 216 and 2.4 meters and subtracting these 216 and 2.4 from both the values of H1 and height of B, we got two values, and we redrew this diagram more simpler than the first one. Then we solved it as usual, and we got scaffolding height as 25 meters at B to be able to see B from A. Okay, I hope it's clear. So we'll move on.